All right, so we want to do 7.4, number 27, which is this thing about a hammer, right? So it says if we drop a hammer, the distance it falls is given by 16t squared. Is that right?
Yeah.
Distance it falls is given by 16t squared. And then they ask us, how long does it take to fall 75 feet?
Approximate to the nearest tenth of a second, the time it takes the hammer to fall.
Okay. So this is not the useful direction. But we can talk about the useful direction in a second. So first things first, I should not panic. I'm having a hard time panicking at this because there's only one number in the whole problem. Well, there's two. There's a 16 and a 2, right? There's not a lot of numbers, which means probably it won't be very hard. Maybe. I don't know.
Hopefully.
Hopefully. Okay, so once I've not panicked, I read it, I got this information out of it, then what? Then I should just drop it off a 75-foot building and time it, right?
Yes, we can find 75-foot building.
So much easier.
That will actually work in this case. The next thing I should do is draw a picture, right? Okay, so we dropped a hammer, and it's got to go, this distance is 75 feet, right?
I think you dropped the hammer, not the guy, right?
I think the force of momentum would be too much.
Oh.
It would kill him.
How tall is the
on
person?
hit.
How tall is the person? I did 75 feet from where the hammer was dropped to the top of his head. Because that's really what you're going to care about. If you want to rephrase this in a less violent manner, put the ground at his head. Right? Take him out of there first, though. Okay, so once I've got my picture set up, what the heck am I trying to do?
You're trying to find the time that it takes for the hammer to drop 75 feet. So you plug in 75 for D and then solve T from there.
You guys see that? This thing, right, is a function. This thing,
16 a rate?
16 is an acceleration.
Physics.
Physics.
Yeah, easy. That's fine. So,
Try this. There's a function, its name is D, right? It takes t's and turns them into distances. T's times, right? Okay, so is the 75 feet, is that a time or a distance?
that's the final distance.
Okay, see that? It's got distance units on it, right? So it's gotta be a distance. So this is an input or an output?
Oh,
You guys all see that? It's gotta be an output because it's a distance. So I'm wondering, right? When is 75 the output of this rule?
when 16 is times T squared.
You guys see this? So then I want to solve this thing, right? Because I'm wondering, when does this function give an output? That's a solve problem. So what do I do?
Divide both sides by 16.
Divide by 16 first.
Yeah.
So I got 75 over 16 is t squared. Then what? Square up both sides? So I got plus or minus the square root of 75 over 16 is t.
Which is going to be 5 times the square root of 3 over 4.
You guys all see that?
Wait, say that one
Wait.
more time.
5 times the square root of 3 over 4. Well, plus or minus 5 times the square root of 3.
Yeah, let's do that a little slower. So when we see 75, what's 75 made out of? If I multiply some numbers together. Yeah, 75 is 25 times 3, right? I know the square root of 25. It's 5. I don't know the square root of 3, so I just write the square root of 3. So here I'm thinking about 75 as 25 times 3. What am I thinking about 16 as?
4 times 4.
16, right? I know the square root of 16. It's 4. You guys cool with this?
Yeah.
Okay, so now what?
Got the answer.
Yeah, I really have the answer.
How would you write that in a sentence?
How would I write that as a sentence? What are the units on this thing? And do I need both of them? You guys see that? There's 2, right? There's a plus and a minus.
Careful,
You
negative C.
can't go negative distance.
No, you're actually going negative time. You can't go negative.
You guys see that? It's time. That means it would hit the ground whatever seconds before it was dropped. That probably doesn't make great loads of sense, right?
Negative.
Okay, so we'll drop the negative 1 on this one. So we'll get t is 5 root 3 over 4. How do I phrase that in a sentence?
The time that it takes for the hammer to reach the ground is 1 and quarter second.
That's just how you.
That makes perfect sense.
It takes this many seconds, right? If this was an easy number, right? It takes 3 seconds would be a perfectly reasonable answer. Yeah? If I'm wondering about how long it takes the hammer to drop, they really said approximate, right?
Oh, that's right.
So how do I get an approximation for this number? Throw it in a calculator.
But,
I'm okay with you guys stopping here.
right.
So that would be a valid answer.
Yeah,
Be like
so this is a
1
valid
and
answer.
so.
Yeah, so ballpark, this is 1 1/4, right? The 5 quarters. This root 3 is
Like 1 point something.
1 point something something. It's someplace between 1 and 2, right?
So it's like 1 and some.
So this is like maybe 1 and change, or maybe low 2, right? You guys see that? It's like 1 or 2 seconds, something like that. Cool?
Yeah, but that guy wants to know how long he has to move.
Yeah, so if you want a better answer, better
Don't
cram
stand
this in a
under there.
calculator.
The better answer is
Is
not
it okay if
stand
I
under
use
there.
like the physics equation for it, which is
No, we just killed
e equals 1
Now
half acceleration times.
How much jail time does that equal?
So this is the physics equation.
Yeah.
That's probably murder, so that's 25 to life.
Right, how long
so-
is that?
Yeah, go for it. The physics equation doesn't require that acceleration be in meters.
Divide time in prison times.
This
time it
is
takes to break
acceleration in feet per second squared.
Over cost of broken hammer.
Cool? Questions?
Can you also do number 17 from the same